If you find that after a decimal point, the digits just keep on looping infinitely and infinitely, whether it's the same number just over and over again, or the same phrase over and over again, we can refer to this as a recurring decimal. For instance, if we just had 0.8888 and it kept going 8s and 8s forever and ever, we could just write this as a shorthand as 0.8 and then put a dot on the top, the signifying the recurring, just because obviously we can't write infinite 8s. So if you ever see a dot on top of a single digit after a decimal point, it's saying that's going on repeatedly. It can also be over 2 digits, however. So if we had 7.65 and both the 6 and the 5 had dots over them, that's saying that it's the 6-5 as a phrase being repeated over and over again. So it's 7.656565 and so forth and so forth. If you wanted to refer to these as fractions, however, that's where you're probably going to have to be dealing with these in an exam paper. If we were just to refer to this as x or some letter, to x equals 0.8 recurring, what we could do is we could times this, for instance, by 10. So we'll get 10x. Now if we times this by 10, we would get 8.8 recurring, because we've moved the decimal point 1 to the right. We now have a single 8 on the left, but then we've still got infinite 8s on the right hand side of the decimal point. To minus these from each other then though, so to just minus x, so we're minusing the 0.8 recurring. This would leave us with 9x. Now 8 minus 0 is still going to be 8, but now everything after the decimal point, because it's identical, because it's all just 8s, they all now cancel with each other, leaving us with just 9x equals 8. And if 9x equals 8, then x is just going to equal 8 over 9. And that's how you can turn 0.8 recurring into a fraction. Let's try again with the other decimal, the 7.65 recurring. If we're just going to label this as x, now if we were to do 10x again, what we would have is 76.5656, so on. Now this isn't good enough, because now what's after the decimal point doesn't match itself. You've got 6565 here, but 5656. Instead, we're going to have to go with 100x, which will then give us 765.6565, and so on. Now that what's after the decimal point is the same, now we can minus. So you do the minus to your regular x, so minus the 7.6565, and together that's going to give you 99x on the left. Now, the 765 minus the 7 is going to leave you with 758. Then again, as before, everything after the decimal point has now cancelled with itself, leaving you with just 558. So, x then will be 758 divided by 99. So that's all you're doing with questions like these. Just label the recurring decimal x, times up by whatever's necessary such that the decimal is still the same, cancel through, and then just divide by what the remaining coefficient of the x is. If you're alright with that, let's try an example of your own. What if we had 4.201 and this was all recurring? The 201 is all recurring over again, so 201, 201, 201, so forth. What would that be as a fraction? If you want to pause the video here and just have a go for yourself, and then press play again when you're ready to compare. Alright, so we're labelling this x. Now in this case, in order to times this up by enough that the decimal becomes the same thing again, we're actually going to have to do 1000x this time, because that's going to give us 4,201.201 recurring again. Taking these away from each other, just so to say the x is beneath, that's going to leave you with 999x being, we're going to be left with 4,197 by doing the 4,201 minus the 4. Once again, all the decimals, because of what we've done, will disappear. This leaves us then with x being 4,197 divided by 999. Simplify, maybe the question asks you to do so. You could also say is 1,399 over 333. With that, let's move on to an actual exam question. Again, as we can see, there's not really much we're going to do with these kind of questions, not much variety. It's going to be they'll give you a recurring decimal and ask you to show that it can be written in a given form, or ask what is it in a fraction form. Here, therefore, we have that our x is 0.0 and then the 4/5 is recurring. In order to get the decimal to be the same then, if we were to do 10x, that would give us 0.4545. That's not good enough because we want the 4 to still be in the second decimal place. So if we do 100x, that will now be 4.5454, and so on and so forth. Now we are in a good position, because if we would say minus the x, that's 0.0454, and so forth and so forth. Minusing these from each other, 100 minus 1 is going to give us a 99x. Now 4 minus 0 is going to be 4. And 5 minus 0 is also going to stay 5. We still actually are keeping one of the decimals this time, but it's then everything after that that disappears. With that in mind then, x on its own is going to be 4.5 over 99, which, if we were just to simplify it, again, you can do that in your calculator, we'll just divide through by 4.5, because 4.5 divided by 4.5 is going to give you 1, and then 99 divided by 4.5 will make that 22, so it's 1 over 22, as they wanted you to show.